Alright, here is our introduction to direct and inverse variations. So before we actually jump into that, I just want to talk about how it's connected to what we've been doing. Actually, anytime you're forming a line where the y-intercept is 0, you're really talking about a direct variation. It's really just when the x gets multiplied by a number and gives you the y value, so that first question in the warm-up is pretty connected to direct variation. Those are actually kind of the same thing. This and this are really very similar, except the line that we're going to graph actually has a y-intercept that's not 0. Direct variation always has a y-intercept of 0. And the slope is actually found in the exact same way. You just count the rise over run, or you can do y2 minus y1 over x2 minus x1, or actually we're going to find an even easier way when we know that the y-intercept is 0. So let's just graph that quickly. I'm going to start at the y-intercept of 5. And then count down 3, so my slope is negative 3 over 1, so I'm going to go down 3 and over 1, down 3 over 1, down 3 over 1, and that forms my line. For slope between 2 points, I'm going to use y2 minus y1 over x2 minus x1, and really just follow order of operations. I'm going to subtract first, and then divide those two. So I'm going to subtract, I'm going to do, this is my y2, that's my y1, so 2 minus negative 7 over 5 minus negative 5, which gives me 9 over 10. The next one, I have to rearrange that so that I get it into slope-intercept form. I really want it to look like this, where y is completely by itself, and then I can just identify the slope from the equation. So all I'm going to do is subtract 7x from both sides. That gives me negative 8y equals negative 7x plus 64. I'm almost there. I really want y completely by itself, so I'm going to get rid of that negative 8. That negative 8 is being multiplied times y, so I'm going to divide everything by that negative 8. So y equals a negative divided by negative is really just positive, so 7 over 8. X, actually I'm pretty much done with this question because it's just looking for the slope. I'm going to write the y-intercept anyway. It's just going to be negative 8, but my slope is 7 over 8. That slope is really all you need for a direct variation. So before we jump into the difference between direct and inverse, I just want to talk about what a variation is. Variation is just talking about how two variables relate to each other. So it's the relationship between two changing numbers, or how two variables relate. And there's other examples of variation, but the two that we're going to be talking about here are direct and inverse. These descriptions are not definitions. These are not perfect definitions of these variations, but they're good rules to follow, especially when you're thinking about word problems, or just intuitively thinking about what is a direct variation, or what is an inverse variation. So, for a direct variation, something like that passes through the origin, and has a positive slope at least, we think of one variable increasing. So as one variable increases, the other variable also increases. For inverse, it's the opposite relationship. As one variable increases, the other variable decreases. Again, this is really not always true, but especially with word problems, it's natural to think about inverse variations in this way, where one goes up, the other goes down. Actually, I'm just going to cover everything on the left side of this first. I'm just going to talk about direct variation, and then I'm going to compare inverse to that, because we know direct variation stuff. Actually, you've been familiar with that for years now. It's really just anytime you graph a line, you're dealing with something that's really similar to direct variation. And we've seen equations like this. We normally think about it as y equals mx plus b. There's one change that we're going to make here. So first off, the b is going to be 0, so we're not going to write that part. But the change that we're really going to make is that the slope is going to be called the constant. And that is going to be k. So the constant of variation is going to be called k for direct and for inverse. For direct, it's really just the slope of the line. And we find that by dividing y by x. Really what we're doing is finding y2 minus y1 over x2 minus x1, but we know that one of those coordinates are 0, 0. One of the sets of coordinates is actually 0, 0, so we don't actually need that part. So don't write this part, but really what I'm thinking about is if I had this equation, y2 minus the coordinates of 0 over x2 minus the coordinates of 0, I really don't need that minus 0 part at all. So I just write it as the y divided by the x. And even another way to think about it is just rearranging this equation. If I wanted to rearrange that equation, I would just divide by x. If I wanted to solve for k, which is what's happening here, I would divide by x and divide by x. And that would give me k by itself equals y over x. So to solve for k, I'm really just dividing those two numbers. Whatever the y is divided by whatever the x is. When you graph it, it's going to look something like this. With a linear constant slope and a y-intercept of 0. It's passing through the origin. On that one, the constant would be the slope, or rise over run, which is 2 over 3. This is maybe the simplest example, because as one goes up, the other goes up. Money is a really easy example with this. So as you work more, let's say work more hours, because we're talking about an actual number. So as the number of hours you work goes up, the money you make goes up. Work more hours, make more money. Inverse is kind of the opposite, where we are talking about these equations actually are not coming out of nowhere. They're really intuitive. Once you start dealing with word problems like this, they make a lot of sense. But for right now, I'm just giving you these equations, and actually you have to memorize these. That and that really just need to be memorized. You don't actually need to memorize both of them. If you know the top one, which for direct is this, and for inverse, it's going to actually be k over x. If you know those two, you can work your way to the constant of variation equation. On this, if I were to solve for k, like is shown there, I would multiply by x on both sides. That would cancel out, and it would give me k equals x times y. Actually, I'm going to flip that order just because in general you see it written like this, y, x, but it's actually the exact same thing. It doesn't really matter. If you want to write x, y, it's really the same thing. But to find the constant for an inverse variation, we're going to multiply the x and y together. And what I really mean is that every time you multiply x times y, you get the same number. That's what the constant really means. It's always the same. So generally, the graph will look like two curves on opposite sides of the graph. So this is in the first quadrant. The other one would be in the third quadrant. And they generally look like that. That's not a perfect graph here, but generally, they're going to be two curves on opposite sides of the graph. So that's one example, those two red lines. I'm going to draw it also in blue, where it's kind of the opposite. I have one in the second quadrant and one in the fourth quadrant. So those blue ones match up, and the red ones actually match up. It's basically just showing that they're on opposite sides of the graph. A simple example of this one is that the more workers we have, more workers, as that number goes up, the number of workers goes up, we have less work to do. Let's say less time working. As the number of workers goes up, the time working goes down, because you get to split the job up among a bunch of different people. these are just general ways to think about inverse and direct variation. Now we're actually going to find those equations.